Okay, so we're going to go over the EOC review sheet. These are released items from South Carolina for fall of 2020. So let's look at the first one. It says the density of an object is related to its mass and volume. The equation below shows the relationship between density, mass, and volume. So I'm going to rewrite that because it's kind of tiny. So D equals M over V. It says which equation represents the volume of an object in relation to its density and mass. So maybe if that sounded complicated, you don't know what they want you to do, but if you look at the answer choices, they all start with what? With V equals. So what do they want me to do? They want me to get V by itself. So how can I get V over here?
Wouldn't you have to, I feel like you'd have to put M on the bottom, V on the top, and then put, I think it'd be a 1 above D.
Alright, so that is a proportion rule. If you put a 1 under the D, there's a rule A over B equals C over D, B over A's equal D over C. So you could flip both sides. So you would get 1 over D equals
V over M.
Yeah, V over M. And then you just got to get rid of the M that's under the V. How do you do that? What does a fraction bar mean? What operation?
Divide.
How do you undo division?
You have to times by M.
So multiply both sides by M. That would cancel. And I'm out of room. But you get, let's go over here, V equals M over D. Because remember, there's a 1 under that M, even though I don't see it. And then multiplying fractions, no big problem. Top times top, bottom times the bottom. Now, what you were saying, the other way you could do this, just for funsies, is you can multiply by V. This will cancel. You get dV equals M.
And then you divide it by D.
And then divide it by D. Both of those work. And one more thing, just for fun, you can do a trick.
I feel like I just did it more standard wise.
Any time you have this situation where something equals a fraction, a ratio, you can just switch those two. So V equals M over D. We do that in pre-cal all the time. All right?
Was the way I did it more like basic, standard?
I think they all work. As long as you get it right, I'm a happy math teacher. All right, so what letter goes with M over D? Is that D?
Yeah.
All right, good. And y'all, like, look at A. A's got a minus in it. Like, where did they, you know? Okay. All right, let's look at number 2. Y'all good? You need a minute. We good? Okay. For number 2, now this was called a literal equation. And for number 2, you're kind of doing the same thing. You've got that perimeter equals, I'm going to rewrite this, 5W minus 13 plus 2W plus 6 plus, now what would you do with this 2 out in front of these parentheses? When you have a number out in front of parentheses like that, what do you got to do? This right here. What do you do with that 2? Distribute. Good. All right, so that will give us 2 times 5W is 10W, and 2 times 15 is 30. So here they want us to add up these 3 binomials. When you add, all you have to do is combine like terms. So what can I hook up with 5W? Five W can be added to, which can be added to, alright, so 5 W's plus 2 W's plus 10 W's is how many W's?
17 W's.
Yep. Then you can put all your constants together. So you got negative 13, positive 6,
49.
and positive 30.
49.
Mm-mm.
Yeah.
Mm-mm.
41.
Y'all, 13 is negative.
Ah.
So 6 and 30 is 36. What's 36?
That'd be 23.
23. Alright, they want you to solve for W. So I want to get W by itself. But first, y'all, look at the answer choices.
Well, obviously, we just gave ourselves the answers and wouldn't have, and the answer wouldn't have to continue beyond that point.
Yeah, you don't, we're gonna finish, but you don't have to finish, yeah. Look, 17 and 23, that's only macking an A, right? 49, 8, 34. So we kind of, know what the answer's gonna be. But let's finish it, just in case the answers aren't as different on the EOC. So to get W by itself, who we kicking out first, 17 or 23? 23, when you kick it to the other side, what's gonna happen to it? It'll become a negative. And then you got a 17 beside, so we will divide. Alright, so W is P minus 23 over 17. Woohoo! Sorry about that. We good? Alright, let's look at number 3. I'll zoom back out a little bit here. Alright, it says, Kaylee is building a rectangular enclosure with an area of 90 square yards. She wants the length to be 6 yards longer than the width, X. To represent this, she writes the equation. So the equation that they give us is X squared plus 6X equals 90. She then wants to complete the square, or she then completes the square. So we just did completes the square to solve the equation for X. So we're gonna do this by completing the square, but I'm gonna show you how to do this on Desmos too. So when you complete the square, the first thing you do is if it doesn't have an X, you kick it to the right. After you do that, where do you look at? You look in front of X squared to see if you need to divide. There's nothing there but a 1, so we're good. Then you look at the 6. What 3 things do we do to 6? First you half it, then you square it, good, then you half it, you square it, you add it to both sides. So what's half of 6? 3. What's 3 squared? 3 times 3 is 9, and you add it to both sides. So 90 and 9 is 99. So just like before, pause on it. Look at your answer choices.
Yeah.
Look.
But we're not completely there yet.
Boom, boom, boom. Yeah, we're not there, but that's the only one with the 99.
But
Now,
another one had a 99.
Oh, I thought it said 96.
I said if another one had a 99, you would have to continue.
Yeah, or you can do the trick.
3 squared.
Yeah, or you can do, I'm going to show you this trick on Desmos. Alright, so this is now a perfect square trinomial. So the square root of x squared is x, the square root of 9 is 3, and the sign is a plus. Don't forget the square. So we know that the answer is B, but I want to show you what you can do on www.desmos.com using the graphing calculator, because you have access to this on the Algebra 1 EOC test. Y'all good before I switch it up? Alright. Whoops. Okay. So I already got Desmos pulled up. So let's say we were not confident in our complete the square skills and we wanted to make sure our answer was right. So first, put in the equation that she gave you. So it was x squared, and then it says, y'all help me, plus 6x equals 90? Alright, so that's the equation that they give me. Now, I can't see all of this thing. Struggling a little bit there. Alright, but I see enough. I'm gonna zoom in, just focusing on the roots here. Alright, right there. You see? Alright, so let's say I thought the answer was A. I'm like, it's totally gotta be A. So A says, parenthesis, x plus 3 squared equals 93. Is that right, y'all? Alright, now look at these two. You see the two different graphs? You see how they're not on top of each other? That means that cannot be the right answer. If that was the right answer, they would be perfectly lined up. So let's put in what we did pick as our answer choice, which was x plus 3 squared equals 99. And then look, you don't see two graphs anymore because they are right on top of each other. So I know that has got to be the right answer. So you see what I'm saying? Even if I didn't complete the square, I could put the equation they gave me and the answer choices in, see if they line up perfectly and know what the right answer is. You feeling me? That's pretty cool, right? Okay. All right, let's go back to number 4. Let me X out of these. Boom, boom. My arm needs to be about a foot longer. All right. Okay. For number 4, it's the same kind of deal. We have, let's see, we have x squared plus 14x plus 37 equals 0. It says Emil is given this equation. He completes the square and rewrites the given equation. Which equation is equivalent to the given equation? I'm saying I'm going to work this out, but in theory, I could go to Desmos, put this in for my first equation, put this in for my second equation, and if they're not on top of each other, that's not the right answer. Okay? So let's complete the square. This time 37's on the left, so what do I got to do with it? All right, we're going to move it to the right. So we'll have x squared plus 14x, leave yourself a little space, equals, what happens when I move it to the other side? It becomes negative. Then we're going to look at 14. What 3 things we got to do to 14? First we half it, then we add it to both sides. Half it, square it, add it to both sides. So half of 14 is 7. 7 squared is 49. Then we add it to both sides. All right. Negative 37 plus 49 is 12. And then on this side, we're going to factor it. So what would happen when I move this 12 over here? Because when I look at my answer choices, do you see how they move the constant to the left side? So if I took this 12 and moved it to the left side, it's going to be what kind of number? Negative. So we know it can't be that. But wait, there's more. Look at your answer choices and look at this equation. X squared plus 14x plus 49.
That's A.
Look, it's got to be A. Because there's a minus in B, and these are both positive. But, just for fun. The square root of x squared is x. The square root of 49 is 7. It's going to be a plus. And then when we move the 12, it will become negative. So we'll have x plus 7 squared minus 12 equals 0. All right, and then again, so solve it by hand, check it on Desmos. You are not timed on the EOC. On Tuesday, you're going to go to first block, they're going to make sure you're here, then you're going to leave and come to my room, and we're going to get started. So you'll have you got all day. But you can relax because you'll have first block and second block before lunch to even worry about it, okay? But you can take all day if you need it. Not time. So I'm going to go to Desmos just to make sure we got it right. I know we did, but, just to reiterate how to do that. So on Desmos, I'm going to put in the original equation. which is x, and here's your little square, plus 14x plus 37 equals 0. And then on the next line, I'm gonna put our solution. We got was parenthesis x plus 7 squared minus 12 equals 0. And look, I'm gonna click back and forth, so just so you can see first one, second one, first one, second one. They're right on top of each other. We know we just got them 2 points. All right, for number 5,
So it's always going to be like this?
Desmos will be available for all your questions. Now you can't use it for everything, but a lot. I'm gonna show you a lot. All right, let's look at the next one. For the next one, it's graphing. Again, you can 100% put this on Desmos. Look at the picture, look at your pictures, pick the right one. But let's narrow it down real quick. Look, this is a greater than symbol. If it's greater than, you color above or below? Above. So look. Next part. Look at the slope. The slope is negative 2/3. So when I look at my line's gonna be going downhill. So this one's going uphill. I'm fairly certain the answer is C. And just off the process of elimination, which rocks. So what we'll do is we'll go to Desmos, we'll put it in just to verify that our answer is right. Okay? Sorry. Alright, so your inequality symbols are down here where you click the little keyboard. So it says y is greater than. Alright, to do a fraction, you just hit divided by. So negative 2 divided by 3. Negative 2/3. Now, I don't want to keep typing underneath, so I'm going to hit, you can either come up here and click beside the 2/3, or you can just use your arrow on your keyboard to the right and it'll scoot you over. X plus 2, and that's what it should look like. I look at the answer we picked, we know we got it right. Amazing. Y'all good? Are you feeling better about it? You gonna make an A? Yes, Miss Lisa. Okay, great. It's not at all awkward. All right, let's look at number 6. All right, for number 6, before we graph it, we would need to put it in what form?
Standard form.
Slope intercept form. So we want it to kind of look like y equals mx plus b. So first we're gonna move at 5x. I don't know if I can zoom anymore. All right, so we have 5x minus 2y is greater than or equal to 10. When we move the 5x to the other side, it will become negative. So negative 2y is greater than or equal to negative 5x plus 10. Back to the side with the y, it has a negative 2 beside it. If it's beside, then you divide. I'm running out of space. If you divide by a negative, I'm gonna write down here. If you divide by a negative, what do you have to do with the inequality symbol? Flip it, yeah. So that'll be less than or equal to, negative is a positive 5/2 x, a positive negative is a negative 5. So the y-intercept is negative 5, the slope is positive, and it's less than, so it should be colored or shaded in below. So look at your answer choices. It's shaded below, it has a positive slope, and the y-intercept is negative 5. What answer has it got to be? D. But we will, of course, check that on Desmos. I'll zoom back out a little bit. And here's the thing. When you put it on Desmos, it doesn't have to be on slope intercept form. So I'm gonna go to Desmos
Trust me, I've noticed that.
and we will type in 5x minus 2y is greater than or equal to 10. And boom shakalaka, we can close that and get a better look. Whoop, there it is. All right. Okay. Flip her on over. Let's look at number 7. Now, this one's kind of a thinking question a little bit. All right, so for number 7, it says Mark hits a tennis ball in the air. He uses this equation, and this equation says h equals, I'm gonna write a little bit bigger, h equals negative 16 t squared, whoops, plus 88t plus 4 to approximate the height h in feet of the ball t seconds after he hits it. So all of this, when you plug in a time, it gives you a height. They want to know, what does the 4, this plus 4, represent in this situation? So the equation, when you plug in a time, it tells you how high the ball is in the air. The plus 4, the constant at the end of the equation, represents what part of the graph? The y-intercept. When we do word problems, the y-intercept is always the what of the equation. Alright, so when you have a real life problem, the y-intercept for linear and quadratic functions is almost always the starting point. So the starting point of that tennis ball was positive 4. So look at your answer choices. It says the ball was in the air for 4 seconds. Does that make sense? What variable deals with time? T. T deals with time because that's in seconds, so no. The ball landed 4 feet away from where Mark hit it. We don't know anything about horizontal distance. It doesn't go with anything we have, so no. The ball was 4 feet above the ground when he hit it. That one would be correct. The plus 4 tells me it had a height of 4 when the time was 0. That is the y-intercept. So that is the starting height. I'm writing all over my other problem. The ball reached the maximum height after 4 seconds. What part, if I graph this, is it a happy or sad face?
Both.
No. It starts with a negative, so what's it going to be? Sad. So it reaches its maximum height at this part of the parabola. What's that part called? It's the max. Good. It's the vertex. So to find that out, we would need to figure out the vertex. And we could do that. We could put this on Desmos and look at it, and we would know that if we needed that. You want to do that? Just to look at it? Or nah?
Yeah.
You can? Well, let's just look at it. It won't hurt anything, right? So if I put this in Desmos, we got, now we don't use h, we have to use y, right? So y equals negative 16x squared plus 88x plus 4. I'm going to do a little zoomy zoom. Alright, so when I go to the vertex right here, I can see that I would have to zoom in a little bit here. Too much zoom. Alright, right here. I can see that it reached its maximum height after about how many seconds?
2.74.
About 2.74 seconds, and the maximum height was, oh, well, there we go. So 2.75 seconds, and the maximum height was 125 feet. Okay, so we know it's not D because it didn't reach its maximum height at 4 seconds. It reached its maximum height after 2.75 seconds. All right, let me scroll back down. Boop, boop. Scrolly scroll. Alright. Okay. That's better. I'm gonna get rid of that. And let's go to the next question. Whoa. Nope, didn't work. There we go. Alright, for number 8, it says a website tracks the number of users it has at the end of its first 30 days since going online. The equation is y equals 15 times 1.03 to the x. Shows the relationship between the days it went online, x. So we plug in days. And the number of users it has, y. Number of users. Whoops. Users. What kind of function is this with the variable in the exponent? We just talked about it. What kind of equations have the variable in the exponent? Exponential, right? So the question is, what does 1.03 represent? So they want to know, what does this part of the exponential equation represent? So let's look at our choices. It says the number of users increases 3 each day, it increases 103 each day, it increases 3%, or it increases 103%. Let's just go look at the table on our calculator and just get a feeling about it. Since we can, why not? So I'm gonna zoom out. How do I graph this on my calculator? What do I press? Press y equals. I don't know if I can leave that on, it's gonna have a glare. All right, so we hit y equals. Well, we turn it on first. Then we hit y equals. All right, and then we're gonna type this equation in. So I'll type 15 parenthesis 1.03, and then to go up to do an exponent, we hit the caret button, and then we'll pick x. This is my x button, like that. And then if I wanna go look at the table, see how it says table in blue? We hit the blue button and then hit graph. So let's look at these values and what's happening. So the first day, or at the beginning, it's 15. Day 1 is 15.45. Day 2 is 15.914. And then 16.391. So look at your answer choices. A says it's increasing by 3 each day. Is it increasing by 3 each day? No. Is it increasing by 103 each day? No. Good. So we're down to 3% or 103%. So is it increasing 3% or is it increasing 103%? 3%. So the answer would be C. Good. All right, and this would be exponential growth, right? Exponential growth. All right, let's look at the next one. Y'all need a second? My bad. All right, for number 9, it says a quadratic expression is shown. So we got x squared minus 100. Which statement best explains why it can be written as x plus c and x minus c? Let's just go ahead and do what it would be for this one. So we got the x, a plus and a minus, but instead of c, what number would go here and here? 10, because the square root of 100 is 10. All right, this is a tricky question because in theory, A, B, C, and D are all true statements. They're all true. But they want to know which one best explains why I can go from this to this. So, is it because it is merely quadratic? No. How about because it's a difference of squares? Yeah, maybe that seems like the best answer. I'm gonna put a little mark, but we're gonna come back and just make sure there's nothing better underneath it. The quadratic expression does not have a linear term. It doesn't have a linear term, but neither does x squared plus 36, and I can't factor this like this. So that's a no. The coefficients is 1. We factored a bunch of stuff with a coefficient of 1, and it didn't look like that. For example, we did x squared plus 5x plus 6. This has a leading coefficient of 1, but it wouldn't be like this. This would be x plus 3 and x plus 2. So that doesn't do a good job either. So B is the right answer. Just to remind you of this formula, because you have to have it to factor stuff like that. The formula for the difference of squares, so if it is a difference of squares, and all that means is you are subtracting, which means difference, and it's 2 perfect squares. So when you're subtracting 2 perfect squares, the way you factor it is if you have a squared minus b squared, like we had x squared minus 10 squared, that's equal to a plus b times a minus b. So that's why we got x plus 10 and x minus 10. This is the formula. You can only use this formula if it is a difference of perfect squares. You okay? All right. Let's look at number 10. We're going to narrow it down, and then we're going to go on Desmos, and I'm going to show you something. So number 10 basically wants us to factor. Now, this is raised to the 4th power, so it's called quartic. So look at these answer choices. 2 of these answer choices would not give you an x to the 4th power. They would give you x to a different power. Which 2 answer choices would not give you x to the 4th power? A would give you x to the what power? Yeah, because this is x plus 3 times x plus 3. That would just give you x squared. So that one doesn't work. Now one of them gives you x to a much bigger power. Which one gives you x to a much bigger power? D. And that would be if you had x squared plus 3 times x squared plus 3, that would end up being, oh, it's to the 4th, sorry, x squared plus 3 and another x squared plus 3. So that would end up with x to the 8th power. So that's too big. So now we got it narrowed down to B and C. And you can think about it, because here you're going to end up having 3 to the 4th, and here you're going to have 3 squared. And look at your answer choices and know which one it is. But let's just say you're having one of those moments where you're stressed and you're just like, I don't know. So I'm going to show you how to do this on Desmos. Even though there's no y equals, we're going to totally make there be a y equals, okay? All the buttons. Okay. All right, here we go. So for the first equation, I'm going to put y equals the thing that they give me. So it'll be y equals x to the fourth. So I hit this a to the b, and I put a fourth. Scooch over, plus 6x squared plus 9. And then on the next line, I'm going to put which one I think is the answer. So let's say I thought B was the answer. So I would put, well, I can't even see this, so let's zoom out so I can see it. There it is. There we go. Well, sort of. I may have done too much zooming. All right, so if I thought B was the answer, I'll put y equals, and then you put what they have for B. So x plus 3 to the, so I'm gonna hit that button, raised to the fourth. Is that the right answer? No, because it ain't on top of each other, or it isn't on top of each other. So let's try C, that's a square, and then in here, instead of x, it's x squared. I mean, y'all, you could work this out by hand the long way, but why do that? So look here, first one, the second one, exact same graph, so I know that that has got to be the right answer. So the answer is C. And if you wanted to FOIL it out just to check, you 100% could. So 2 options. I'm gonna go down here. You could always use the formula a plus b squared equals a squared plus 2ab plus b squared. Or you could just do x squared plus 3 times x squared plus 3. And there's 2 of them because it's squared. And then x squared times x squared is x to the fourth. X squared times 3 is 3x squared. 3 times x squared is 3x squared. 3 times 3 is 9. Hook up these 2 bad mama jammas, and you get x to the fourth plus 6x squared plus 9, which boom shakalaka is what we had. But we just reviewed some stuff, so that's cool. Y'all ready for the next one? Nope. Sorry. Let me zoom in a little bit. There we go. Alright, so let's look at number 11, and I've written all over it. Alright, number 11 says the function f of x equals 4 times 0.5 to the x gives the remaining amount in grams of a radioactive substance after it has been decaying for x minutes. So x, your domain is in minutes. F of x, your range is in grams. What does f of 4 equals 0.25 represent in this situation? So, what kind of function is this? Where the variable is an exponential. Good. So this is exponential, and it's decay because this is only a half, so it's in between 0 and 1. So if I see a 4 right here, that means I'm plugging in 4 for x. And we know, according to this problem, x is in minutes. All right, when we plugged in a 4, we got 0.25. So my y is 0.25, or my f of x is 0.25. And we know that that means grams of radioactive substances. I'm sorry, I don't mean to laugh. All right, so let's look at our answer choices. A couple of these answer choices have numbers that we have not even mentioned. So which answer choices can we kill? A and B. Like, I don't know. So C and D are so similar, it's scary. C says after decaying for 4 minutes, there is 0.25 gram of the substance remaining. D says after decaying for 4 minutes, there is 0.25 of the original amount of the substance remaining. Go back to the word problem. What does the word problem exactly say about f of x? It says the remaining amount in grams. So is it going to be C or D? C. Yeah, it doesn't say anything like the original amount. The original amount is right here. 4 is the OG, the original amount. OA, original amount. I don't know what's OG. So C is the correct answer. But y'all see how they try to be tricky? They basically wrote the same thing twice. They just added a couple of sneaky words. So look for stuff like that. Evil math people. So whatever is right here, that's your starting amount. It's decaying because this is less than 1. And this is the time that we're doing the decaying. All right, let's look at the next one. All right, for this one, it says Reggie carves and sells wooden sculptures online. He uses the function f of x, let me write that down. F of x equals 15x plus 60 to determine the price. So your output is the price for a sculpture that took him X hours. So hours. So X is independent, that's your domain. We input hours and we know how much Reggie's gonna charge for that wood sculpture. What kind of function is this? Right, it's linear. Okay, so it says, what does f of 75 mean? They want to know, what does that mean? So we're plugging in 75 for x. So that means it took him how long? 75 hours to carve something. So if we want to know how much it's going to cost, we'll have to plug it in. So f of 75, f of 75 would be 15, I'm almost out of room, times 75, I'm going to have to write underneath it, plus 60. So what is 15 times 75 plus 60? All right, what'd you get?
1,185.
Yeah. So, which answer choices would that be? D. It took him 70, that's forever. It took him 75 hours to carve whatever. I'm going to say it's a bear because that's all the wood carvers I ever see. It took him 75 hours to carve it, and he's going to charge $1,185 for his sculpture.
I would have said an owl.
I would have liked it better if it was an owl. Y'all good? Let's look at number 13. It says a quadratic function is shown. So we got y equals x squared minus 14x plus 33. It has two x-intercepts. What is the equation of the axis of symmetry? Now, we could do some math. We could find this out, or we could graph it and look at the picture. The axis of symmetry is the line that does what? That's right, it cuts the parabola in half. So let's go to Desmos and let's graph this bad mama jamma. And let's just get it. The formula for the axis of symmetry, if you wanted to do it the old school way, would be x equals negative b over 2a. Alright, so let's put this in. So we got y equals x squared minus 14x plus 33. Alright, let me do, did I type that in right, y'all? You know I'm blind. Is that right? Thanks. So I'm going to go down here, zoom a little bit more, and click on the vertex, maybe. Alright. So there's the vertex. It's at 7, negative 16. So the axis of symmetry, look at your answer choices. Which one would it be? It'd be C, x equals 7. Because if I graphed x equals 7, it would run right straight down the middle here and cut my parabola in half. So the answer is x equals 7. Back it back up. Whoop, whoop, whoop. Alright. So the answer is x equals 7. We use Desmos, old school way. A is whatever's in front of x squared, which is a 1. B is whatever's in front of here, which is negative 14, whatever's with my x. So if you did negative b, it would be negative 14 divided by 2 times a, which would be negative is a positive 14. 2 times 1 is 2, and 14 over 2 is 7. All right, let's look at number 14. You okay? Need a second? My bad. All right, for number 14, uh-oh, got zoomy. All right, it says, which equivalent form, of g of x equals 2x squared minus 12x, so let's write that, 2x squared, g of x equals 2 of x squared minus 12x minus 54 is the best form to find the zeros of the function. Remember, zeros, I really need more room. Zeros are the same thing as x-intercepts, which are the same things as the roots, which are also called solutions. So they could say all those things. So I'm going to use Desmos to do this, and I'm going to also use this saying I told y'all. Hold on. Here we go. And the little saying is, roots are real, factors are fake. Remember I said like some of your friends? Roots are real, factors are fake. We're going to graph it, look at Desmos, find the roots, and whatever the root is, the opposite of that is going to be the factor. Alright? Alright. Let's go hitting on Desmos again. Really? Remote? Okay. Alright, so we got, alright, g of x is just a fancy way to say y, that's function notation. Y equals 2x, oh dear, 2x squared minus 12x minus 54. So I'm gonna have to do some major maneuvering in my graph here. I'm gonna zoom out just to help me get to the roots faster. I am going the wrong way to get to the roots. Alright, here we go. Alright, so looking at this graph, where are my roots at? Where are my x-intercepts, my zeros, my solutions? What two numbers?
Negative.
-3. Whoops, come on now. And 9. So y'all remember this. I'm gonna turn this off. -3 and 9. -3 and 9. Come on. Okay. So if my roots are at -3 and +9, my factors are going to be the opposite of -3 and the opposite of +9. So it'll be x plus 3 and x minus 9. So what's the answer got to be? C.
Hey, I did do that one right.
I mean, you would, y'all, the reason the 2 is out front for C, I don't know if I can zoom in anymore. All right, the reason why there's a 2 out front is because I could divide all these by 2, and then you can factor it. But you guys, if you know what the roots are, it's got to have factors that are the opposite. Because roots are real, factors are fake. We good? All right, let's move on to the last page. We might have to do a little zoomy zoom here. All right, let's look at number 15. And this one doesn't require math so much as thinking. It says, which situation can be modeled by an exponential function? So photos cost 8 cents each. I buy one photo, how much does it cost? 8 cents. I buy 2, how much does it cost? 16 cents. I buy 3, how much does it cost? 24 cents. So what kind of function would that be? Linear. Good. So that is not exponential in any way, shape, or form. All right. Let's look at D. It says the number of gallons in a water tank decreased by 52 each day. Decrease is what operation? It's just minus, right? So that means it would be minus 52, minus 52, minus 52. Is that exponential? No, that's linear also. So this one was linear, and this one is linear. All right, we down to population increasing 3% or pay being $12.25 an hour plus 5% sales commission. So do you think it would be B or C? B. Y'all, almost always, population growth is exponential. Population growth, bacteria growth. So if it's increasing 3%, your equation would be whatever the original population was, and we don't know what that is, so I'm going to just put P for population, times 1 plus 0.03 for that 3% to the T being time in years. So that is exponential growth. I'll write it down here. Exponential growth. Are we good? Times and by percent, exponential. Number 16 is kind of strange. All right, for number 16, that's a lot of, y'all see all is reading. But if you took the biology one, it's not as much as the biology EOC. It says, Victoria and Roberto are climbing stairs in a building. They're raising money for charity, but how they will get their money is different. Victoria receives donations from people who give a fixed amount for each flight of stairs she climbs. So that means every time she climbs a flight of stairs, booyah, she gets that money. Let's say it's $20 just for fun. So one flight, $20. 2 flight, $40. 3 flights, $60. Now, Roberto was a little smarter about this deal. He receives donations from people who give a fixed amount regardless of how many flights of stairs he climbs. So he went up and he's like, hey, will you give me a donation? You're like, sure. Here's $50. He could climb 2 flights of stairs. He could climb 10 flights of stairs. He already got that $50. You understand what I'm saying? So it says, these two write an equation to represent the total amount of money their team raises. Why? So Y is the total amount. Based on the number of flights of stairs Victoria climbs, X. Which statement best describes the equation? So let's look at the first differences here. We got linear, linear, exponential, exponential. So you're getting money every time she climbs a flight of stairs. Is it going to be linear or exponential? It's linear, because you're plussing that same amount every time she climbs a flight of stairs. So it's totally not exponential. So now we're down to A or B. A says here's the difference between A or B. It says some money that does not depend on how many flights of stairs, and B says that it's at a constant rate for each additional flight of stairs. So does it depend on how many flight of stairs? Yeah, because she's getting paid. Look, it says she gets donations for each flight of stairs. So does it depend on how many flights she climbs? It does, because the more she climbs, the more money they get. So A is wrong, because it says does not depend. It would be B. And y'all, it says right here in the equation, based on the number of flights she climbs, X. So it's like A is controversy to this statement right here. Controversy. Yeah. All right, we good? No math, just thinking. I think everybody can definitely do number 17. We good? All right, number 17 says, Central High School has 1,023 students. Approximately 75% of the students attended the last home football game. Which attendance number is the most appropriate estimate of the school students who attended the last football game? So number one, estimate. Do we know what that means? Yeah. Which two answer choices are 100% not an estimate? C and D. Y'all ever went to a football game and said, oh, it looks like 1,000.4 people are here? Nobody does that. That's not an estimate. So what is 75% of 1,023? How do you do 75% of 1,023? What operation will we do? Multiply. So we'll just do, I know we're not estimating when we do this, but if we do 0.75 times 1,023 or 1,020, I'm going to do 1,023 because that's just how I roll. So 0.75 times 1,023 will give me 767.25. So what would the answer be? B. But do you see how that was one of the answer choices? What we got exactly was an answer choice. If you did not read that word estimate, you would have marked the wrong answer choice. So just be careful. Again, tricky. All right. Let's look at number 18. Yesterday, they had a hard time remembering that kind of problem. So for number 18, they gave you, this is a radical, and they want you to change it to a rational exponent. Whoops, sorry about that. Let me zoom out. A rational exponent. So you have the fourth of x to the fifth. So we're going to have our x here as our base, and I'm going to draw a fraction. Rational exponent, rational just means it's a fraction. What do you call this? This is a what? What is this thing right here? What am I doing? What's that called? What is that? A square root. Root. Where do roots go? my root, I need to put it on the bottom because it's got to go in the ground. 5 is your exponent, and the exponent goes on top. So the answer would be D. I want to do another one of these just to review real quick, okay? So what if we had the cube root of y to the 6? Okay, so I'm going to put my y in my little fraction bar. What number goes on bottom? What's my root? 3. What number goes on top? Now, can we simplify that? What's 6 over 3? 2. So it's just y squared. So sometimes it's useful to change it from radical form to rational form because you can simplify it easier, in my opinion. 2 more, people, and we're going to be done. Everybody got these? Okay. All right, let's look at number 19. It says, which expression is equivalent to this? All right, so look at this thing. 86, x to the half, y to the 2/3. Which 2 answer choices do not make any sense whatsoever? C and D. Why? Because why are they putting 86 in the square root? You can't put baby in the corner. It's just 86. 86 is 86, and it's got to be free to be 86. Now, if you had 86x and some parentheses and a 1/2, that's different because 86 would get that 1/2. But this 86 is out front. It's the coefficient is macking. It's just 86. So these 2 answers. Now, we're going to use what we just learned, but do it backwards. Let's just focus on the y. So you got y to the 2/3, and I want to change it from a rational to a radical. So y goes in here. What is my root? 2 or 3? 3, because roots are in the bottom. They're in the ground, right? So 3 is my root. 2 is my exponent. And just by doing that, I know the answer's got to be what? A. It's got to be A. You guys, x to the 1/2 is the same as the square root of x. When you see a 2, this is a square root. We just don't write the 2 when we do a square root. The square root of x is x to the 1/2. All right, one more. And I know you know the next one. Like, seriously, the next one, you 100% is easy breezy lemon squeeze. Y'all good? Okay. All right, what is this called? Scatter plot, yeah. It says, Annabelle collects litter alongside the road near her house for 8 days. She's a good Samaritan. She keeps track of the plastic bottles, X, and aluminum cans, Y she finds on the road for 8 days, blah, blah, blah. Here's her data. It says the correlation coefficient is 0.78. So remember, the letter we use for correlation coefficient is R. So R is 0.78. And you got your dots. If you wanted to, with your plotted points, you could draw, what do you call this? When you draw that to best represent the data? Line of best fit. So if we wanted to, I'm not going to, well, I could whip out a ruler. I'm going to sketch kind of what I would see as a line of best fit here. It says,
it would be C, a strong positive relationship.
Yeah. It says which best describes the meaning. Okay, well, what kind of number is this? Negative or positive? Positive. And you can see the slope is positive. So negative is, and then it's strong or it's weak. Remember, the closer it is to the number 1, the stronger it is. And the closer it is to 0, it's weaker. So 0.78 is closer to 1 than it is to 0. So like he said, it would be strong. All right. Hope that helped. Have a great day.